Good day, sir. Today I'm going to demonstrate the Eplan 1A. So the materials that we needed, the two pairs of protractor triangles, compass divider, and pencil. And the last chart, the chart number 9. So I'm going to the scenario description. At 13:30 hours, the vessel is at the vicinity of the west part of the Panay Island on course 200 degrees through with speed of 10 knots with a falling tide. Falling tide means pataog. The OW observed the Pushupi lighthouse. It bears 230 degrees relative with a distance of 7 nautical miles. After 30 minutes, the same object was observed, and this time it bears the 250 degrees relative. So, before we plot the bearing start, uh, just need to convert into the true bearing. So, I'm going to performance criteria, plot the first LOP in COP of Pushupi Lighthouse at 13:30 hours, and apply the international notation convention for the first LOP in COP. So, I'm going to convert the first observation of the first LOP, which is the Pushupi Lighthouse. So, the 330 degrees relatives plus the ship shading, which is 200, equals 530. To exit, minus 360 equals 170 degrees true bearing. In the second bearing, 270 degrees plus ship shading 200 equals 470 degrees. To exit, minus 360 equals 110 degrees true bearing. So I'm going to plot the first observation of the Pushupi lighthouse. This is 170 degrees from Pushupi lighthouse. After that, don't forget to put in the level on the first observation of Pushupi lighthouse, which is 13:30 hours and 170 degrees true bearing. And then calculate the distance run after an hour from the first observation. So with the speed, which is 10 knots, uh, convert into the 10 nautical miles. So plot the dead reckoning position at 14 hours. At 13:30 hours, so it is the 13:30 minutes. So I'm going to plot the speed is 200, 200, and then to get the nautical miles, so distance, so speed times times, so which is the 10 knots times 30 minutes, which is the 14 hours and 13:30 hours, which is 30 minutes, divide 60, so equals 5 nautical miles. So I'm going to get the 5 nautical miles here. So nice. So that is the dead reckoning from 14 hours. After that, um, Plot the second LOP of Pushopiti Lighthouse. Apply the international rotation convention for the second LOP. Plot the estimated position at 14 hours. So, kuan man siya falling tide. So, it is 1.4 knots and times 30 minutes times 30. So divide by 60. So the answer is 0.7 nautical miles. At 7 nautical miles, 0.7 nautical miles. Here, that is the that's what we called estimated position. What is a 14 hours from the second LOP. LOP. In fact, another the 170 degrees. And then after that, determine the ship running fixed position. Apply the international convention notation for the running fixed position. So from the 110 degrees true bearing, to get another bearing from 110 degrees true bearing. Ito from Push Your Pretty Lighthouse. And then determine the latitude and longitude of the ship running fixed position at 14 hours. And then latitude and longitude. So sa atong chart kay wala may siya ikuan sa longitude to get for to the latitude. So the answer of the latitude it is 11 degrees and 45.8 nautical miles. So that's all. Thank you.